This is a word problem involving maximizing revenue. And most of the maximizing revenue word problems are going to take the same kind of a format. It is problem number 55 on page 242 of your book. So it says an online music store sells about 4,000 songs each day when it charges $1 per song. So as I go along in these problems, I just kind of jot down the information to see what it is I'm going to need. For each 5-cent increase in price, 0.05 increase in price plus 5%, about 80 fewer songs are sold. So I need to develop a quadratic function to find out how the store can maximize their daily revenue. All right. Well, so this is kind of an interesting problem. The first thing I have to know is that revenue, R-E-V-E-N-U-E, revenue, is equal to the price times the number of units. And we can see that pretty clearly with the information they gave us to start with. They sell 4,000 units a day, 4,000 songs a day, at $1 per day, at $1 per song. So the revenue, that is the money that they take in, I'm making hand motions now, the money that they take in, we're not talking about profit because we don't have any cost involved. We're just talking about the money that they take in, would be 4,000 songs times $1 per song, so they're making $4,000 per day. Well, I'm going to make some changes here. But I'm going to do it, I'm going to show you how to do it. Maybe it'll help if we make two columns. So we have the price and the number of songs. And we know that revenue is equal to price times the number of songs. So we know at a price of $1, I sell 4,000 songs. Now if I subtract a nickel, so I'm going to subtract a nickel, 0.05, wait a minute, retract that. When I add a nickel, I'm selling my songs now for $1.05. I'm going to sell 80 less songs. So I'm going to sell 3,920 songs. When I add another nickel, my price is now $1.10. And I'm going to sell, what is that? 3,840 songs. So I subtracted 80 again. If I add another nickel, I'm selling them for $1.15, and I'm only going to sell 3,760 songs. So I subtracted 80 again. So what we can see here is that every time I raise the price a nickel, the number of songs go down by 80. So I'm going to make an equation to represent those two factors. My initial price is $1. And when I add 0.05, I do it X number of times. I did it once, twice, 3 times in this particular example. That is my price. And the number of units I'm selling started at 4,000. But each time I add a nickel, I lose 80 songs. So I'm subtracting 80 times X. My x is the same in both cases. My x represents the number of times my price went up by 5 cents and the number of times my number of songs went down by 80. That is what my x represents. So try and kind of think that through when you see these kind of problems. Well, now I have an expression for my price, and I have an expression for my number of songs. I know that revenue is equal to the price times the number of songs. So that's what I'm going to do. I'm trying to find out a quadratic model for revenue because I want to maximize my revenue. So I'm going to do this. I'm going to say that revenue is equal to 1 plus 0.05x times 4,000 minus 80x. I'm going to FOIL that out. And when I do so, I get this. 1 times 4,000, 4,000. That's my first. My outer, negative 80x. My inner, positive 200x. And my last, negative 4x squared. Well, I think it'd be much better if we write that in standard form. So I get r is equal to negative 4x squared. Now I'm going to combine these two like terms and get plus 120x plus 4,000. So there it is in standard form. And I'm happy about that. I'm happy about that in large part because I have a negative sign in front of my highest term of x, which means that my parabola, because it's a quadratic, my parabola is going to open downward, and I will, in fact, have a maximum value. And that's what I'm looking for, is to maximize my revenue. Well, if I'm maximizing my revenue, I'm going to have a parabola. It's going to have a maximum value. But I want to think about what this graph is going to look like. So this graph has a y-axis and an x-axis. And if we go back and think through what our problem is, our x value here is equal to the number of times I make this change of adding a nickel and subtracting 80 songs. So my x is the number of times I add 0.05. And my y is my revenue. And my measurement, I can either call this y is revenue, or I can just call it dollars. Because revenue is measured in dollars, so that would be okay. But important is to understand that the x does not represent dollars, but it represents the number of times I'm changing the price, which is also the same number of times that I'm reducing the number of songs. Well, I know I'm going to have a parabola of some sort, and I know that a parabola has an axis of symmetry, and that my vertex of the parabola is the maximum value if the parabola opens downward. So I need to find the x value, which will give me the number of times I increase the price by 0.05. I need to find the axis of symmetry. So the axis of symmetry is represented, I have my equation here for revenue in standard form. The axis of symmetry is negative b over 2a. Well, that would be negative 120 divided by 2 times negative 4. So that's equal to negative 120 divided by negative 8. Whoa, what happened here? Go away. Okay, which is equal to positive 15. But axis of symmetry is at 15. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here is positive 15. Here is my axis of symmetry. So I have a parabola going on here somewhere with that axis of symmetry. And I know that my maximum value is going to sit right there on that axis of symmetry. And I know the x value of that, of my vertex. So I know the x value of my vertex. I know what my equation is right here. So what I'm going to do is I'm going to evaluate r of 15. I'm evaluating my function r for revenue for the x value of 15, which is the number of times I need to change the price by 5 cents. So that is equal to, I'm going to look at it here, it's negative 4 times 15 squared plus 120 times 15 plus 4,000. Now let me just pause here for a second and tell you I'm going a little bit beyond problem 50. Because problem 50 says, well, use the verbal model and the quadratic function to find how the store can maximize daily revenue. So if you got just up to here and say it has to increase the price 15 times by a nickel, that would be fine. That would be the answer to this question. I'm pushing it a little bit farther. I want to find out what the maximum revenue is, and I'm going to graph it and just show you a couple things. If you want to stop the video right now, go ahead. You'll know that it increases 15 times. It'd probably be a good idea to know that that is 15 times 0.05, which means I'm raising the price by 0.75. I'm raising the price by 75 cents. And the final price means I should be charging $1.75 for each song to maximize my revenue. Well, let's just kind of continue on here and see how this works. I'm going to now use the calculator a little bit. And I'm going to put my y equals, I'm going to put my equation into my y equals. I'm going to put it into the calculator. So I have negative 4x squared. You can see the buttons I'm pushing, they turn up red on the calculator as I push them. Plus 120x plus 4,000. That's my equation. I'm going to go back to my main screen by pushing second quit, second mode. And I'm going to evaluate that function for 15. So I'm going to go alpha F4, that's alpha trace button. And I get this little box right here, which offers me all of the different y values that I have input into my calculator, and I put that equation into y1. So I'm going to press enter, and it says, okay, y1, what do you want me to do with that function? Well, I want you to evaluate that function, parentheses, for 15, which is the number of times I'm increasing the price. I press enter, and it tells me if I do that, then my revenue, so R of 15, is going to equal 4,900. So let's just evaluate our data that we have so far. We know that we have to increase the price by a nickel 15 times. That's 75 cents, leading to a price of $1.75. We know that we started with 4,000 songs, but we subtracted 80 songs 15 times, leading to the number of songs, I better calculate this before I talk. Well, I can do it over in the calculator. Leading to 4,000 Doesn't work when I'm holding that. Sorry. 4,000 minus 80 times 15. 2,800 songs. That's a lot less. I'm selling a lot less songs, but at a much higher price. For a total revenue, 2,800 times 1.75, and I get 4,900, which was the total revenue that I calculated when I evaluated the function at 15. So I hope you're kind of seeing how these things are all tied together. Let's see if we can look at it on a graph. I'm going to go over here to my y equals. My equation is in there. I'm going to get out of that. Now I'm going to go zoom 6. It's always where I start my graphs. And I can see that my graph isn't showing up. Because if I just look at my formula, at my equation here, my r equals, I can see that I have a y-intercept of 4,000. Standard form, ax squared plus bx plus c. C is our y-intercept. So I have a y-intercept of 4,000. And when I go zoom 6, I'm going from positive 10 to negative 10 to negative 10 to positive 10. And well, that's nowhere near 4,000. So I'm going to change my window. And since I know it's a parabola, and I know it's going to probably go up somewhere here, and I know that the maximum is going to be 4,900 because that's what I discovered down here, I'm going to focus on my y maximum, and I'm going to make my y maximum 5,000. Now, I also know that my vertex is at x equals 15, right here. So I want to make my x value, my x maximum greater than 15. I think I'll make it 20. I think I'll change my scale to 2s, just so that it looks a little bit better. And on the y-axis, I'm going to change my scale to, I think I'll change it to 500s. I usually kind of take the range from, or the maximum and divide it by 10. That's what I use for my my scale. And now I'm going to push graph, and there's my nice parabola. Look at that. You know what? I can kind of see that my maximum is in this range right here, because it's going down. You can see it take that little notch right there. But it isn't quite as pretty as I would like. So I'm going to change my window, and I'm going to make my x maximum a little bit bigger than 20, so it extends out farther. I'm going to make it 40. And I'll change my scale to 5, and I'll push graph. Oh yes, that's a much nicer parabola, don't you agree? So I know from my calculations that my maximum point in here someplace is going to be at x equals 15. And I know that that maximum value is going to be y equals 4,900. But it would be nice to see how to use the calculator to test that. Well, okay, I'll do that. I'm going to erase these here, otherwise the calculator doesn't work very well. And I'm going to test it. I have my parabola. I'm going to go second, calc. And I want to find the maximum. Well, the maximum, I press 4 to find the maximum. And it's asking me, I need to define the neighborhood where that maximum is. If I define the neighborhood wrong, then I'm not going to get the right maximum. We know that the maximum, let's get ourselves a little bit of space here. We know that the maximum is 4,900, and it's where x is equal to 15. We know that's a fact by our calculations. We're just kind of testing it. So what I'm going to do to start with, just to show you how this works, is I'm going to set my neighborhood at my left bound for x is equal to 5, and my right bound for x is equal to 8. So you can see that I have defined my neighborhood between these two arrows right there. And you can also see that my maximum, which is up here someplace, is not in that neighborhood. So if I define my neighborhood wrong, I don't want to make a guess, I'm going to press enter. It's going to give me a maximum value, but that maximum value is 4704. And that is where you can see my parabola is going up. That's the maximum value in the neighborhood that I gave it. So it's very important to pick the right neighborhood for your left bound and right bound. So I'm going to go again, I'm going to go second, calc, and I'm going to do maximum. And I want my left bound, well, I'm expecting it to be around 15, so I'm going to make my left bound 10. And I'm going to press enter, and see I get this nice arrow that just popped up right here. And that is at x equals 10. And I think I'll make my right bound at 20. So I'll press enter. And now I have a nice arrow over here at 20. And I can kind of see by the way my graph looks that, yeah, my maximum point is somewhere in that neighborhood. So I'm pretty comfortable with this now. So I set my left bound and my right bound. It's indicated by those two arrows. And I'm going to press enter because I don't want to make a guess. And what do you know? My maximum shows up at x equals 15, pretty close, it's a pixel off. And my y is equal to 4900, just as I had expected. So there's a little lesson on how to do one of these word problems and how to use the calculator to do it.